In this lesson, we are going to have the goal and be able to say that I can write an algebraic expression to represent the information presented in a real life situation. But before we do that, we need to go through a few things. We have some vocabulary. We need to make sure that we remember what an expression is. We need to remember what a variable is and a constant. These are not new words. These are words you guys have seen before. These are words that we have talked about in other lessons, in other videos. So just to quickly refresh, an expression is a mathematical phrase with variables, numbers, and operations. Let me give you an example. Let's say we have 3x plus 7. That is an expression. It does not have an equals to sign. It's just expressing what it is. Okay? So that is what an expression is. A variable, that's the x values. It could be x, it could be y, it could be z, it can be a. Whatever letter we want it to be, typically not e because e is Euler's number. So we don't do that, and we typically do not put I either as the missing variable. So variables, we could have x, y, z, and a whole sort of others. And it also depends on the situations. If we're dealing with time, we typically like to use t for time. If we're dealing with hours, so that's being a little bit more specific about the time, we usually use h. If we are using miles, we might use m. It just depends on the situation. Variables are nice because it helps us to be able to represent lots and lots of numbers and be able to plug in any number into that situation. The number constants are numbers that do not have variables beside them. So this 7 in this expression is a constant. It does not have a variable beside it. Some other words that I did not put on here is, or another word that I did not put on here, is contextualized meaning. Basically that is, we are trying to understand what it means within the context, within the real life situation. So for our vocabulary, that's just a quick refresh about what those mean. So we are going to do this quick example. We're going to be able to write an an expression. A gym charges $25 for each fitness class. And we're going to call that class C. We're going to use C for that because we're talking about a class. We could have used F for fitness, but we're going to use C in this case. And $40 for each personal training session. We're going to call that P because we're going to say that that's for the personal training session. Write an expression for the total cost. Okay, well, we know that the fitness class, we do not know how many classes we actually have. So we're going to do a class, but we also know that they charge $25 for every single class. So that would end up to be $25 times how many classes we have. $25 times however many classes we have. Then the other part of this is we have the $40 for each personal training session. Personal training session, we could have 1, we could have 2, we could have 3. It just depends on how many we have. So we are going to put the P beside that because it's $40 for every personal training session. So for one training session, it's $40. For 2 training sessions, it's $80, and so on. But writing the expression, if we want to know the total cost of this, it would make the most sense if we try to add it. If we're adding the two prices together, we're going to end up with the total cost. If we are subtracting them, that's going to be finding the difference between the two. So words in this lesson are going to be key for us to be able to write an expression. So this right here is going to be our expression to be able to find the total cost. Example number 2, or another example. A bakery sells a box with 2 muffins and 3 cookies. Let M be the price of a muffin and C be the price of a cookie. Write an expression representing the cost for 7 boxes. So here's what we're going to do. We know that M is the price for the muffins, and we have C, which is a price for the cookie. They decided to use uppercase letter for this one, and that's okay to use uppercase letters. So we know each box has 2 muffins in it. But we don't know how much those muffins cost, each of them. So we're going to put M beside the 2. 2 of those times whatever their price is. If the price was $1, then together it'd be $2. If the price was $3 for each muffin, that's going to be a total of $6 for those 2 muffins, and so on. Then the other part of this is the cookies. We know we had 3 cookies. So 3 times whatever the price is. Remember this, the variables in this case is price. The other ones is how many are in each one. And if we're trying to find how much it's going to cost, we're going to end up having to add them together again. If we're trying to figure out if what's the difference in between the 2, if we bought more of one than the other, then it might be a different operation. However, that's not all the way what they are asking for. The last part of it says, write an expression representing the cost of 7 boxes. Oh, well, we're buying 7 of these boxes, so instead of writing 2m plus 3c plus 2m plus 3c over and over and over again, we can just say, well, we're just going to have this box of our muffins and of our cookies, and we're just going to take that and do it 7 times. So we're going to end up putting 7 on the front. It's a multiplication of 7. So this would be fine to be able to have as your answer. However, I would like us to take it a step further and simplify it. If we want to simplify this, we have parentheses, we have a number outside. We are going to be doing our distributive property. I believe I mentioned distributive property in our last video. Our distributive property means we take the number outside and distribute it evenly among the 2 terms. So we go 7 times the 2m. 7 times 2 is 14, so we have 14m. And we do plus, because it's positive, 7 times 3c. 7 times 3 is 21, so 21c. Notice there are no like terms. The m and the c are different variables, so we cannot put them together anymore. So that would be our expression fully simplified. Here's another example. A taxi ride costs $3 plus $2 per every mile that he takes you. Write an expression for the total cost. Well, to just get into the taxi, he's charging $3. So we're going to say plus 3 onto whatever we have. Plus $2 per mile that we go. So I'm going to put the 3 up front, and then we're going to put the plus afterwards, the plus sign after. Remember, addition's commutative, so it doesn't matter whether we put the plus in front or behind. Commutative means if we have the 2 numbers and add them, it does not matter the order we add them. If we take 7 and 5, that's the same thing as 5 and 7. So $3 plus $2 for every mile that we go. Let's say that this is going to be m. Let's use a variable m for mileage. So 2 times however many miles we go. If we go 1 mile, that's $2. If we go 2 miles, that's $4. If we go 3 miles, that's $6. If we go 4 miles, that's $8. Added on top of the price to just get into the taxi for the service. Write the expression for total cost. That's it. There's nothing more that we need to do to that. So that would be the answer to this example. Moving on, we have write an algebraic expression for each description. By the way, whenever you're doing this, there is a helpful handout on the website. You may want to take a look at the helpful handout because it takes the words and gives you an example for those words and also shows you what it means in an algebraic way. So you will want to look at the helpful handout on the website to be able to help you out with understanding what some of these words mean. But anyways, we have part A, which says the sum of 3 and the product of 5 and x. Well, sum means to add. It is a result of an addition. So we are adding 2 things. We are adding 3 with something else. We're adding it with the product. The product means to multiply. So we're using the sum of two numbers, then we are multiplying it to something. We're adding it to the multiplication of two other numbers. The product is of 5 and x. So this would be the expression from those words. The sum, which is the addition of the two objects, of 3, so 3 goes in front, and would be where the plus goes, this other thing that's happening, this product, which is the multiplication. Part B says that 7 less than twice y. Twice means that we are doing 2 times that amount. So 2 times y. With this one, wording, we have to be careful with wording with this one. Less than. 7 less than this other. Less than is typically associated with subtraction. On the helpful handout, there is another spot which could be with inequalities, but there's also keywords whenever you're doing that. If it says is less than, then that would be inequality. But because it says just less than, it's a subtraction. So 7 less than this other object. So are we saying that we are going 7 and minusing 2y, or are we trying to say that we are going 2y minus by 7? We're trying to say it's 2y minus by 7 because we are taking 7 away from this other object. 7 less, we're taking that away from another element. Part C says the quotient of m and 4. Quotient is division. So we're doing the division of m and this other thing, 4 plus 6. I don't know why there's a comma there, but there shouldn't be. So the quotient of m and 4 plus 6. So on the bottom, we're going to have, oh, I see what happened. There is supposed to be that comma there. The quotient of m and 4, so m and 4, plus 6. So we are going to add 6 onto the end of this. So be very careful with the wording. The quotient of m and 4, so that's grouped together. They have the comma there to say pause. Take a moment. Look at what this is. And then they say plus 6 onto whatever that was. So that's why it is m divided by 4 plus 6. Part D. The difference between 10 and the product of 3 and a. Difference means to subtract between 10 and the product of 3a. Difference means to subtract two things. We have difference between 10, so 10 and the product of 3 and a. Product we already said was multiplication, so we're multiplying 3 and a. So 10 minus by 3 times a would be the expression for that one. Part E, and this is actually our last part. The product of negative 5 and z increased by 12. We already said product means to multiply. Negative 5 and z. If we are increasing, that is being added on top of. So we are going to add 12 on top of that value.